How do you know? Interesting, isn't it? Okay, well noted. All right, so the vector data model, like I said, is actually, it allows precise representation of geographic features. So let's go to the board and look at it. So here, vector for a field, yeah, this is not regular, but I'm just using the board. So this is a football field. Okay, all right, but there's a lot going on. We take a football field in Ghana, not the AstroTurf for a proper football field. You realize that some places may be, you know, graveled, some places are green, some places are like that. So there's what we call spatial, you know, variation. Okay, or spatial heterogeneity is better. Heterogeneity, as opposed to spatial homogeneity. Okay, homogeneous. Okay. There's a lot of changes going on the park, but with the vector seem to box it all and make it just, you know, one single object. Okay. So that's the problem with the vector data model. But then we end up also storing only a few points. 1, 2, 3, 4. But what does the raster model, what does it do? It divides the whole area into squares. It tessellates. Okay, so instead of using the word divide, if you use the word tessellate, you know, people will respect you. Are you okay for saying that? They will think you are deep. Yeah. All right. And then it stores the values in here. So this could be, you know, vegetation, values for vegetation will be stored in all this, and there will be numbers. Are you okay? 2, 4, etc. 20, whatever these values are. Are you okay? Now, so we get to know, but then in doing that, we end up storing how many squares? Column number 1, 2, 3, 4, 5, 6. Then 7, 8, 9. Okay, then 1, 2, 3, 4, 5, 6, 7. So 7 times 9. Are you okay? That's 63 or so. So now we have to talk about 63, 60 plus points. Whilst in the vector, we are storing how many? We are storing only 4 coordinates. And that is why when you store a lot of images in your computer gets full early. When you look at my laptop like this, it's full, and I'm wondering what's in it. It's because of some of the things I'm storing. Are you okay? It's not necessarily pictures per se. Of course, software also takes a lot of space. But this is one of the reasons why your phone will get full, your laptop will get full, because you're storing images which are actually modeled on the raster data. Okay, model. So the quality of cartographic output is great. Okay, what does it mean? Cartographic output has got to do with creating a map. Okay, so we have any map that you pick, normally is actually what? Vector. It's vector because it looks nice. Okay, it looks like all the maps you are using, Google Maps, they are all modeled on the vector model, and the raster becomes an option. You choose to look at the raster. You can go raster. It depends on resolution. You may not like it. Okay, it may not look so nice. It's not aesthetically pleasing. Okay. So functional tools of operations like map, projection, overlay, analysis are available. We can do a whole lot with the vector model. Discrete features such as customer locations and data summarized by area are usually presented using a vector model. Yes, you can't store customer locations using squares. Are you okay? Or you can't be taking the pictures of your customers and be analyzing them. How? Are you going to look at their beauty, or how are you going to go about it? So what you do is that you use the vector model, which now captures their location. Are you okay? I.e., we are talking about Ghana Post GIS. What do you call that? Ghana Post GPS or something like that. Ghana Post GPS. So the Ghana Post GPS then is converted into a point, even though, you know, we all know it's not really a point. It's some kind of generalized location going on there. All right, so that is the vector model for you. Meanwhile, the raster model, I think we said a lot. I think I'm repeating myself. Please, guys, let me skip all this. It's easy to really represent continuous data such as elevation. I think it makes sense. If I'm storing the location, if I'm working on a particular project, and I need to look at how the surface is changing in elevation and height, then I would like to go for something like raster, which will give me the location of every single point continually. All right, so then of course you depend on the resolution as well. So take note of that. All right, a few advantages. Data can be represented at its original resolution and form without generalization. That's subjective, isn't it? All right, subjective. But then if I'm interested in like representing a building, then of course I just pick the corners of the building. I may end up missing one or two things, but I'll be okay. Okay. All right. So this is how the building is. I can represent that. Meanwhile, the raster. So we are giving these advantages with respect to the raster, because the raster now can't represent the corners of a building this way. It will end up putting a lot of squares. Are you okay? Just to represent this. All right. So let's look at the second one. The graphic output is usually more like it's beautiful to look at vector. It's very nice to look at vector. Since most data are hard copy maps, then we need to convert. Okay, so in the past, there were no good cameras, there were no satellite images and stuff like that. So most data that were captured in 1844, 18 something, they were all vector. A lot of mapping that was done then were all vector. So you may need to do a conversion. Okay, so we are saying that that is it's an advantage that we don't have to do a conversion if it's raster. I mean, we are in vector, so we don't need to convert. The data existing data is in vector. We don't need to convert. All right. Accurate geographic location is maintained. Yes. If there's a tree, I pick the GPS, coordinates of that tree, and that's it. So accurate geographic location of data is maintained. It allows for efficient encoding of topology. I think we talked about that. That topology is not relevant in the raster data model. It's only relevant and efficiently can be done in vector data model. Please, I'll be asking you interesting questions, so pay attention. Take note of that. This one is okay. Topology is not relevant in the raster data model, but it is in the vector data model. Now, the disadvantage is that each location we have to store it. Well, we have to store it. So why is there a disadvantage? But yes, the raster doesn't have to do that. Okay, because the locations are actually inferred in the structure. The very nature of the raster gives the location, the row and column numbers. Okay, for effective analysis, vector must be converted into a topological structure. So the fact that you've captured data in vector doesn't mean it's topologically right. I hope you can justify what I just said. The fact that you have data in the vector data model doesn't mean that it is topologically correct or it is in a topological form. The fact that you have data in vector form doesn't make it what? Topologically correct. Okay, so here what is happening? This is not enclosed. Meanwhile, the intention of getting this data was that we wanted to pick a building, isn't it? There's another problem here. It's not reaching it, but it's a T-junction. So we have an issue. Are you okay? We have an issue. All right. So these issues, mean we need to be resolved. They need to be resolved. Okay. And it becomes a disadvantage. And we may also need to rebuild the topology, something called rebuilding topology. In other words, you can click a button and then the computer will tell you where the issues are. in the data set. Okay, all right, and you need to do that, and it may just take some time, but it's okay. So topology is static. All right, so it means it's not like on the fly, it's not dynamic. Something is not static, it's not that, it means it's not dynamic. It means that as you put in data into GIS, it doesn't just figure out that something, some line isn't reaching another line. Okay, algorithms for manipulative and analysis functions are complex and may become a processing intensive. Okay, you can look at it. We are saying this because in the raster data model, it's easy to write an algorithm or a program. An algorithm is like a program, are you okay? Which eventually behind every software we have an algorithm. Okay, so we are saying maybe processing intensive because in the raster it's very easy. Okay, so today people have phones for IG, okay? What is IG? Instagram. And then they take a picture and then some, you know, they turn in your nose into some bunny and all that. All that is raster, you know, manipulation going on there. Are you okay? So let's understand the topic very well. Let's really get it. Continuous data such as elevation. If you want to represent elevation data in vector, you are representing it as spot height. So the surveyor is picking points and then he's putting it on the plan, showing that, okay, the height here is this, the height there is that. And normally it's in a grid. The points are arranged in a grid structure. But you will realize that the grid, yeah, in between the grid points, there could be something happening there that you will miss. So continuous data such as elevation that is not efficiently represented in vector form. Raster will try to get you the height everywhere. Depending on the resolution, you will love it. You will love it, and you can use it for as a model that, you know, is going to help you. Okay. Spatial analysis filtering within polygons is not possible. Of course not. All the things that we are doing with our phones and changing it into black and white and all the kind of manipulation that is being done on the smartphones, for example, cannot be applied to vector data. Is that okay? So in AutoCAD, for example, which AutoCAD actually handles virtually vector data. Are you okay? All the things you are doing in AutoCAD is vector. Okay, except if you want to overlay, you can't do what we call spatial analysis and filtering with it. You can't. It's just not possible. But there are millions of algorithms for doing hydrographic analysis. Are you okay? If you want to look at the rivers and how they are flowing, and you know what we call watershed, we'll talk about vector view sheds very soon, and you appreciate it. Raster advantages are like vector disadvantages, and then raster advantages are like vector disadvantages. You can just swap them if you get into trouble. Okay, so geographic location of each cell is implied by its position. So if you go and look at the raster, the vector side, you realize that we have to explicitly, explicitly store the corners of, the particular feature of interest for the objects. You have to specifically, explicitly. Meanwhile, here it is implied. So that's what I'm saying that. So that one explicitly storing coordinates is a disadvantage, but here we have, the geographic location of each cell being implied by its position in the cell matrix. Are you okay? So we are talking about something like I, J. Are you okay? So if you go back here, then obviously we can say that a particular cell, if I take, for example, this cell, then the actual, the location of this cell is implied by this column here. Okay, and then this row here, and that's IJ in maths. So like matrices. Are you okay? Then so this what makes the algorithms easy to write. Okay, already I'm writing on. So if I want to go to the next cell, I plus 1, J. Okay, takes me to R, C, Okay, so then you see I'm already writing a program to manipulate this. All right, so there we go. All right. The inherent nature of raster map is one attribute map is still suited for mathematical modeling. I think that is just what I just talked about. It's easy, okay, to manipulate it. Discrete data is accommodated equally well as continuous data. Okay, that's interesting. It's subjective because discrete data is like data that should be represented as polygons, like farmlands. Are you okay? Farmlands, the constituencies, the districts, all of that are discrete data. And he's saying we can equally, but subjective. Grid cell systems are very compatible with raster cell output, grid cells, example, electrostatic plotters, graphic tuners. These are used, anything that allow you to capture data in a grid, on a grid, will work very well with our raster data model. Disadvantage is that cell size determines resolution. So if someone gives you a low resolution satellite data, raster data sets, you can't do much with it. And some of the advantages we talked about will become disadvantages because of the resolution. Is that okay? All right, so cell size determines the resolution at which the data is represented. It's especially difficult to adequately represent linear features. So if I want to represent a river using the raster, it's going to be very difficult. Very, very difficult. So let's say I want to represent this using the raster. The vector is saying just pick points. That's all. Pick the point, okay, that define the shape of the object. That's vector. Join the points with lines and you have a polyline. You are done. Okay. And it's looking like what is on the ground. What does the raster do? It says divide the area into squares, and then I want you to start capturing, capturing every square, approximate whatever you find there. Here there's, so if this were a river, we are saying there's water here. Meanwhile, there's water is not everywhere. Okay, water is only along the line. So then the resolution comes in and then it becomes a disadvantage. So the same thing applies to everywhere the water is. And we need to also store values for everywhere there isn't water. So I think it's clear to you. Processing of associated attribute data may be cumbersome. Obviously, the data set is huge. Are you okay? The data that you have, large amounts of data. It's huge. Like you storing 1 gig of some raster, satellite data. Are you with me? All right, so we have to take note of this advantage. Oops. Okay, how are you going to? All right. Since most output data is in vector form, data must have to go vector to raster. This is some kind of disadvantage for the two systems that once you find data in raster, you may want to convert it to take advantage, okay, of any kind of any advantage in raster that you want. You have to convert the raster into vector to take advantage of that. All right. Most outputs of grid systems do not conform to high quality. Obviously, that's one. Raster is not always nice. It's not good for presentation. If you go and show, if you go to say parliament to give a presentation and you start showing them satellite images, seriously, they may not like it. I don't know. Don't challenge, don't go and try it. Okay. A lot of people don't like you. They don't like your presentation. But you will never understand. It will take years for you to understand that. It's because you're using the satellite image. Pictures are nice, but if a picture with a low resolution, especially, is going to give you serious issues. If you look at a vector map of Ghana, you're going to like it more than the raster representation, because the raster representation is going to show you all the nasty stuff, okay, and all the filth. Are you all right? But the vector is going to cover all that and generalize, and even rubbish is going to look nice in vector. Are you okay? All right. So, but I think it's got something to do with the resolution. Is okay. So everything in raster depends on the resolution. All right, I think we talked about this disadvantage. I think we're probably done with this one. Okay, any questions can come through. How much? Let me see how far we've gone. 1:45. We started 11:30. Thereabouts.
Yes, sir. Please, can I ask a question?
Please ask a question. Ask a question. Yes, go ahead.
Yes.
Mm. Ask a question. Go ahead. We are waiting for you. Ask a question. It's question time. Anybody? Because the questions that you are going to be asked are very tricky. So please, the questions you ask me are very important in that case. If it's a traditional exam, you can go and chew and pour. These questions are simply made to be tricky so that you don't get it right. Simply because you can copy. Are you okay? So please, understanding it is very important. Ask your question and then I'll give you an answer for it. I'm still waiting for whoever wants to ask a question. I'm still waiting. I'm still waiting.